All right, let's look at the homework 12.4, problem number 10. All right, so let's look at that. It says that a wrench 30 centimeter long lies along the positive y-axis. All right, so you have some sort of a wrench. All right, so I'm gonna just have a wrench. All right, so something like that. Right, and this is say center right there. All right, it's 30 centimeters along the y-axis. So I would say I'm gonna call this vector r. So that's the vector from here to the tip. All right, so this is going to be, so there's no component in x, and the y component is 0.3. So I want to put it in meters. So 30 centimeter is 0.3 meters. And then there's no z component, so we have that. All right, then the force is applied in the direction. So let's say I'm gonna put a force, say I've just put the direction here, and then this is I'm gonna call this guy F. All right, then so it's in the direction. We don't know its magnitude, so what I'm gonna do is, we know the direction, so I'm gonna make it a unit vector. So unit vector would be 0 comma 3 comma -4. Then we would have to divide it by its length. So it's a square root of 0 squared is 0, 3 squared would be 9, and -4 squared would be 16. Right? So this would give us a unit vector in the direction of the force, then multiply by whatever the magnitude of the force, which we don't know. So I'm going to put the magnitude of the force F. All right, so this is going to be, let's see, square root of 25 is 5, so it's going to be a magnitude of F divided by 5. Then we have 0 comma 3 comma -4. All right. All right, so let's try to find the torque here. So remember that the torque, tau, is going to be just a cross product between r and the force vector F. Right? So this is going to be, right, so we have, let's see, I, J, K. All right, so it's going to be 0, 0.30, right? And here, a magnitude of F over 5 is just a number, so I'm going to just put it outside. Magnitude of F over 5. Then you have a 0, 3, -4. All right. Then this is going to be, all right, so whatever this guy is, we don't know that yet, over 5. All right, so first component would be, so you have 0.3 times -4 minus 0, so -1.2. All right, the second component would be this times that minus this times that is actually 0. And the last component would be 0 times 3, 0 minus 0. So it's actually, we get that. All right. Then we know that the magnitude of the torque is 120 Newton times meters. So magnitude of the torque vector is going to be, all right, so we have a magnitude of F over 5, and also the magnitude of this vector, so it's going to be square root of -1.2 squared plus 0 plus 0. So this is going to be actually this is 1.2. So 1.2 over 5. then magnitude of F, right? And we want this guy to be 120, right? So what you get is going to be, we want to say multiply by 5 over 1.2. So that way we can isolate the magnitude of the force. So 120 times 5 over 1.2. All right. So if you cancel these out, so this is going to be divided by 1.2, so it's 100. So 100 times 5 would be 500. All right. So 500 would be the magnitude of the force. All right. So let's type it in here. All right. So magnitude of the force is 500 newtons. All right. Let's check the answer. All right. It came back and looks like we got this one correctly. All right. That's it. I hope that this was clear.